Before writing smart contracts, you need a dependable workspace. In this module, we'll connect familiar Ethereum tools, Solidity, Hardhat, Truffle, and MetaMask, with Hyperledger Besu, so you can build locally, test safely, and prepare for real enterprise deployment. You've already built the foundation, what Besu is, where it fits, and how enterprise networks are structured and governed. Now we move from design decisions to hands-on readiness, setting up the tools you'll use to write, test, deploy, and connect smart contracts on Besu. Your development environment is the control point for everything you build with Besu. It keeps compilation, testing, and deployment predictable, so the same project behaves consistently across machines. It also gives applications a reliable path into Besu through JSON-RPC. Before anything reaches a private or permissioned network, you can test locally, catch mistakes early, and reduce setup-related failures in team workflows and CI/CD pipelines. The Besu toolchain has three main layers. At the node layer, Java runs Besu directly, while Docker supports repeatable containerized networks. At the application layer, Node.js and NPM support the JavaScript tools developers use every day. At the smart contract layer, Hardhat, Truffle, Web3.js, and Ethers.js help compile, deploy, test, and interact with contracts. MetaMask and your editor round out the workflow with accounts, signing, debugging, and productivity support. Before running Besu directly, start with Java. Install a supported JDK, typically Java 17 LTS, and make sure Java home points to it. Then open a terminal and run Java version to confirm the active runtime. After installing Besu, run Besu version as a quick sanity check. Whether you use binaries, packages, source builds, or containers, keep versions consistent across your team. Docker gives you a clean way to run Besu without turning every laptop into a custom setup project. The image packages Besu with the runtime dependencies it needs, so teams can start from the same baseline. With Docker Compose, you can define multiple Besu nodes, expose JSON-RPC on ports like 8545, and recreate a private network consistently. That makes demos, CI tests, resets, and multi-node simulations much easier to manage. For JavaScript-based Ethereum development, Node.js is usually the starting point. Node provides the runtime, and NPM brings in the packages your project depends on. After verifying NodeV and npm-vv, create a project folder, run npm init, and install a framework like Hardhat or Truffle. From there, npm scripts can compile Solidity, run tests, deploy contracts, and support front-end libraries like Ethers.js or Web3.js. Use env when teams need consistent Node versions across machines. A good editor removes friction from the development loop. Visual Studio Code is a common choice because extensions can support Solidity, JavaScript or TypeScript, JSON, Docker, and Git workflows in one place. Linting catches problems early, formatting keeps code consistent, and GitLens helps trace changes. Debugging shortens feedback loops. The integrated terminal is especially useful for running Besu, Hardhat, Truffle, and npm scripts without switching context. For teams, workspace settings make those conventions repeatable. Hardhat and Truffle solve the same core problem: compiling, testing, and deploying Solidity contracts against Besu through Ethereum-compatible APIs. Hardhat is often favored for newer projects because it is flexible, plugin-driven, and commonly paired with Ethers.js. Truffle offers a more established workflow, especially around migrations and long-running enterprise practices. In most cases, the choice is less about raw capability and more about team standards, project structure, and tooling familiarity. To use MetaMask with Besu, add your Besu node as a custom network. Enter the JSON-RPC endpoint, for example, http://localhost 8545, and set the chain ID to the exact value your private network uses. If the chain ID does not match, transactions may fail or point to the wrong network. Then create or import development accounts, connect the wallet, and send a small test transaction. Never use real keys in local environments. Besu fits into the standard Ethereum development workflow. Developers write Solidity contracts, compile them into bytecode, and deploy them to a Besu network. The ABI tells applications how to call those contracts and interpret responses. JSON-RPC gives tools a common way to communicate with Besu nodes, while libraries like Web3.js and Ethers.js make those calls easier. That means existing Ethereum skills and tooling can carry directly into enterprise Besu projects. Contract development on Besu feels familiar if you already know Ethereum. You start with Solidity, then produce the two key artifacts, bytecode, which runs on-chain, and the ABI, which applications use to interact with it. Automated tests validate behavior before deployment. What changes is the target environment. You might deploy to one local Besu node, a private multi-node network, or a permissioned enterprise environment with stricter access controls. Choose your local setup based on what you need to learn. A simulated chain is fastest, making it ideal for unit tests and quick contract iteration. A single Besu node adds more realism, especially around JSON-RPC behavior and client compatibility. A private Besu network takes more setup, but lets you test consensus, permissions, and multi-node topology. In practice, mature teams move through all three as confidence grows. The safest approach is to build your environment in layers. First, get Node, NPM, your editor, and Hardhat or Truffle working with basic contract tests. Then add a local Besu node through Java or Docker and verify the RPC endpoint directly before involving MetaMask or application code. Most setup problems come from mismatched chain IDs, blocked RPC ports, Java version issues, empty accounts, or dependency conflicts. Test each layer before moving on. You now have the foundation for Besu development: Ethereum tools, JSON-RPC libraries, Solidity workflows, and local network choices. Java and Docker help you run repeatable environments, from simulated chains to private Besu networks. Next, we'll build on this by learning smart contract fundamentals, deployment, integration, and enterprise design.